Hello dear students, I am back again with the next two questions. So in the last video we have seen question number 1 and question number 2 of last year's In-Sem question paper. Is it? So today we are going to see the question number 3 and question number 4. So first of all we will see the question number 3. In that first question is there, that is what? Explain the 3 stages of pH metric titration between HCl and NaOH with titration curve and reaction. So this question is for 5 marks. So how it is distributed for 5 marks? First of all, you have to explain the 3 stages of pH metric titration, and these three stages will be for 3 marks, and then you will have to draw the titration curve. This will be for 1 mark and the reaction will be for 1 mark. So like this 5 marks are there. So first of all we will see the 3 stages, which are the 3 important stages are there. So you can see here, first of all initial stage is there, then before equivalence point stage, at equivalence point and after equivalence point. So these second, third and fourth, that is before equivalence point, at equivalence point and after equivalence point. So these 3 stages are very much important, and that you have to explain here. So as you can see that in pH metric titration, when we are taking the HCl, suppose in pH metric titration HCl is the strong acid and NaOH is the strong base, and when we are doing the titration of HCl versus NaOH, then what type of graph is there? So you can see the graph is like this. So what happened in this graph? Here you can see that at the starting, when you are taking the pH of the HCl solution, as HCl is strong acid, so it dissociates completely into the solution. So this strong acid, it is having its pH value is very low. So at the starting you will get the point at low pH. Okay, so this is the what initially when we are adding the NaOH to the solution of HCl, then this HCl dissociates completely and it is having very low pH value. Then before equivalence point stage, when you are going to add NaOH to the HCl, then what happen? The slowly pH is getting rises, because NaOH, when you are adding NaOH solution to the HCl, that is strong acid, then the H plus ions are getting replaced with Na plus ions, means the HCl is slowly it is getting neutralized with NaOH ions. NaOH, okay. So because of that the pH is slowly increasing, and what happens at equivalence point, you can see that the all HCl, so HCl is getting neutralized with NaOH. So at the equivalence point here you can see that the pH is 7, because here neutralization takes place and the whole acid is getting neutralized with NaOH, and the pH of that solution will be 7. Then after equivalence point, what happened after equivalence point? If you are going to add further NaOH solution to the HCl, then what happen? This solution will becomes basic, okay, and because of this alkaline nature, so the pH of the solution, it is getting increased. You know that pH of the acid, the range of the pH of the acid, it is 0 to 7. The neutral solution, it is having pH 7, and the basic solution or alkaline solution, it is having the pH 7 to 14. So because of that the pH value is getting increasing, and this is how you can see the graph, that is the strong acid versus strong base. So this is the pH metric titration, that is strong acid versus strong base. So this is how you have to explain these 3 stages: before equivalence point, at equivalence point and after equivalence point. What things occurs, and you will have to write the reaction. When you are going to add when you are going to add NaOH to the HCl solution, then there is a formation of NaCl plus water, that is salt plus water. So this is how you can write the answer of this first question. Then the second the question number 3b is there. What is that? Give construction working with diagram of glass electrode. Okay, so here this question is for 4 marks. So here you can see that the construction, this will be for 1 mark, working will be for 1 mark, and the diagram will be for 2 marks. So this is how you will get the 4 marks. So first of all, what is the construction of this glass electrode? Here you can see that in diagram. So this glass electrode, this is having very thin wall glass. Okay, so this is having thin wall glass, which is at the end, which is having bulb. Okay, so in that bulb, silver wire is dipped. That silver wire which is coated with silver chloride. Okay, so this is dipped into the 0.1 molar of HCl solution. So this can be you can be explained this in the construction. Okay, then working. In the working, you can write down the representation of the glass electrode and the how it works, how does it measures the H plus ion concentration from the test solution. So it measures the H plus ion concentration from the test solution. Here you can see that. So this potential of this glass electrode, it can be determined with the help of standard calomel electrode, and when this glass electrode it is deep into the test solution, then there is a difference in potential of the H plus ion concentration. Okay, so along this membrane there is a difference in H plus ion concentration in along this membrane, and because of this difference you can measure the H plus ion concentration in the test solution. So this is how you can write the answer of this question. Here what is there? Here you can see that this is the construction point. So in this construction you can write this is the glass tube which is filled with 0.1 molar of HCl solution, and this is a thin wall glass membrane and in which silver wire is dipped into the 0.1 molar of HCl solution and which is coated with silver chloride. Okay, so this is how you can write the answer. Then next question is there. Give composition of membrane of ion selective electrode which is used to detect. Here three ions are there, H plus, F minus and Cl minus. That is hydrogen ion, fluorine ion and chlorine ion. So you will have to write the composition to detect this H plus ion, F minus ions and Cl minus ions. So just write down the answer of this, how they are composed. Okay, and this is for these 3 ions will be for 3 marks. So already you know that how this glass electrode is constructed, that also that we have seen in the last question. So this glass electrode, it consists of a very thin wall glass bulb, okay, which is made from the very low melting point glass because of to have a high electrical conductivity. Okay, and this bulb contains 0.1 molar of HCl solution, and this is coated with this HCl. In that HCl solution silver wire is there and which is coated with silver chloride, and that is deep into this 0.1 molar HCl solution. So this is how this glass electrode is constructed, and that composition only you have to write down. Okay, so how this glass electrode is there is. Okay, then now the next question is, that is third C, that is give composition of membrane of ion selective electrode used to detect these 3 ions, H plus ions, F minus ions and Cl minus ions. So now here what you have to give, you have to give the composition of membrane of electrode which detects the H plus ions. So to detect the H plus ions we use the glass electrode, you know that. So this glass electrode, it is consist of very thin wall glass which is made from the low melting point glass to have high electrical conductivity. So this is the composition of the membrane. So this membrane, the glass electrodes membrane, it is made up of thin wall glass, and this is having a high electrical conductivity, and this only you have to mention in the answer. So this is if you are going to mention this only, then also you will get the marks. And you can add these additional topics, that is the bulb contains 0.1 molar of HCl solution, silver wire which is coated with silver chloride that is deep into that 0.1 molar HCl solution. Okay, so this can you add. Okay, then the next is F minus ions. So to detect the F minus ions, the electrode, which is the electrode's membrane, its composition is, this membrane, it is made up of lanthanum trifluoride crystal, which is doped with europium fluoride, which is mixed. Doping means which is mixed with europium fluoride. So lanthanum trifluoride crystal, which is doped with europium fluoride, and the crystal, it is sealed at the bottom of the polymeric container, which is containing internal reference solution. So in that internal reference solution, sodium fluoride with in presence of sodium chloride, or potassium fluoride in presence of potassium chloride is there. So mainly here you have to mention that there is a membrane to detect the F minus ion. So the membrane is made up of lanthanum trifluoride crystal, which is doped with europium fluoride. So that is your main answer. Then to detect the chlorine ions, that is Cl minus ions, so the membrane, it is made up of palette of Ag2S and AgCl, that is silver chloride. This is used in the composition of the membrane of the electrode to detect the Cl minus ion. So that is your main answer, and this electrode is made up of Teflon, and the palette is attached using epoxy resin. Okay, so this is how you can write the answer of this question. Now the next question is there, define equivalent conductance. So what is meant by equivalent conductance? When two electrodes are placed apart at 1 centimeter, then the conductance of a solution which is containing 1 gram equivalent of the electrolyte at particular concentration, then this conductance is known as equivalent conductance. When the solution containing 1 gram of equivalent of electrolyte, when two electrodes are placed apart at 1 centimeter. Then molar conductance is there. So molar conductance, same type of definition you have to write here, only instead of 1 gram of equivalent of electrolyte, here you have to write down 1 mole of the electrolyte. Okay, so this is only the difference between these two, molar conductance and equivalent conductance. Then you have to define the cell constant. You know that the cell constant, this is the ratio of L by A, this is known as cell constant. So L is the length and A is the area of cross section between the two electrodes. So here cell constant is equal to L by A, or it is also you can define as, it is the ratio of specific conductance divided by major conductance. So if you are going to write this one only, then also you will get the marks. So this is for 3 marks. So 3 definition for 3 marks. Then next question is there, you have to explain conductometric titration curve for neutralization of strong acid versus or using strong base. Okay, so here strong acid, again we are going to take the example of HCl versus NaOH. So HCl is the strong acid, NaOH is the strong base, and here which type of titration you have to do? Conductometric titration. Now in this conductometric titration, again you have to explain this stages. Which stages? Initial stage, before equivalence, at equivalence, and after equivalence. Okay, so before equivalence, here also here you can see that, so initially the conductance of the solution will be high, because HCl, when we are taking the conductance of the HCl, that is the strong acid, so this strong acid dissociates completely and there is a formation of H plus and Cl minus ion, and initially because of that the conductance will be high. Then before equivalence point, when we are going to add NaOH solution to the HCl, then what will happen? The highly mobile H plus ions will get replaced with less mobile Na plus ions, and because of that the conductance is going to be decreased. And at equivalence point, so all HCl is getting neutralized with NaOH solution and the solution becomes neutral. Okay, and after equivalence point, if we are going to add further NaOH solution to the HCl, then what will happen? again because of the NaOH, that is the strong base, because of this strong base again the conductance will going to be increase. So here you can see that the graph. So at the starting, when we are measure the conductance of strong acid, at the starting conductance is high. Then when we are going to add NaOH solution to the HCl, then because of because of replacement of highly H plus ions with Na plus ions, the conductance is slowly going to be decreased, and it is decreased till the equivalence point. So here all HCl is getting neutralized with NaOH, and after equivalence point, if you are going to add further NaOH solution to the HCl, then there is a addition of NaOH, and because of this NaOH ions there is a conductance is getting increasing. So this is how the V-shaped graph you are getting here. So the important things here you have to write, that is you have to write the stages of the 3 or 4 stages you can write here. Mainly 3 stages you have to write here, that is before equivalence point, at equivalence point and after equivalence point. And then the graph is necessary, and one more thing, that is you have to write the reaction. So here a reaction is not given, but you know that the reaction is there. What is that? HCl plus NaOH, then you will get NaCl plus water, that is salt plus water. So that also is mandatory to write here. Then you will get the 5 marks. Then next question is there. Give construction working with neat label diagram of calomel electrode. So here you have to give the construction of the calomel electrode, then working of the calomel electrode, and you have to draw the diagram also. This is for 4 marks. So again the construction will be for 1 marks, working for 1 marks, and diagram for 2 marks. But here in case of glass electrode, its working points are very less. So here working point is more. So here you can distribute like construction will be for 1 marks, working will be for 2 marks, and diagram will be for 1 marks. So total 4 marks are there. So here you can see that calomel electrode, it consists of outer glass tube which is fitted with the frit at the bottom. Frit means porous like structure is there at the bottom to permit the conductivity. Then another glass tube is there. Inside that another glass tube, here Hg is there, that is mercury is there. Above that mercurous chloride paste is there. Above that paste there is a KCl solution, and here platinum wire is sealed into that calomel electrode. Here you can see that this is how you can write the construction of that calomel electrode. Then through the salt bridge another electrode is attached to complete the cell. Okay, and the representation of the cell, you can see that mercury is it is in contact with mercurous chloride paste. It is in contact with KCl solution. It may be X molar. Okay, if we consider it X molar, then in the working what you can write. So you know that calomel electrode, it is a reversible electrode. So in that calomel electrode, when this mercury is going to be act as an anode, then what will happen? When mercury is acting as an anode, then it will lose the electron. There is a formation of Hg plus ions, and this Hg plus ion here, when this mercury, when it is acting as an anode, so this mercury will lose the electron. There is a formation of Hg2 plus ions. The electrons will be loose, and from this KCl solution, the Cl minus ions will get react with this Hg, and there is a formation of Hg plus Cl minus. Here there is a formation of mercurous chloride paste. Okay, so when this calomel electrode acting as a anode, that means when this mercury is acting as a anode. Then when this calomel electrode acting as a cathode, then what happen? This mercury it gains the electron here. So Hg2 plus ions which is formed here, that will gains the electron, and then there is a formation of mercurous chloride paste. So here you can see the reaction. Hg2 plus ions which gains the electron, there is a formation of mercury and mercurous chloride paste. It is disproportionate into mercury ion plus Cl minus ions. Okay, so this is how the reaction will take place. So what does it indicates? When this mercury or when this calomel electrode, it is acting as an anode, then the thickness of Hg is going to be decreased. That means this Hg will loses its ions, that is it will lose its electron, and then there is a formation of Hg plus ions. The thickness of Hg will going to be decreased, and thickness of mercury mercurous chloride paste is going to be increased. And when it is acting as a cathode, then thickness of that paste is going to be decreased and thickness of mercury is going to be increased. So that you have to write here. So this is how the this calomel electrode is working. So it is acting as a reversible electrode. So it is a reversible electrode. When it is acting as anode, then the mercury is going to be decreased, and mercurous chloride paste, the thickness of this paste is going to be increased. Okay, so that you have to write here. Electrode potential of the other electrode on hydrogen scale, it can be measured when it is combined with the calomel electrode. So additionally you can write this point. Otherwise this is the working of this calomel electrode, and these points are important. Now the next question is there, that is write two advantages of instrumental methods of analysis and give stepwise process for calibration of pH meter. So what are the advantages of the instrumental methods of analysis? So first of all, we need a very small amount of substance to analyze. Okay, then determination of this instrumental method, it is considerably, it is fast. So these two advantages, these are sufficient. You can add one more advantage, like it is the accuracy of this instrumental method analysis, it is more. Okay, then process of calibration of pH meter. For this process, first of all, you can see that first of all your pH meter, turn on the button of that pH meter. So turn on pH meter, then prepare a buffer solution. So with the help of buffer solution, you can calibrate the pH meter. If you are going to use the, suppose for example you are going to use the buffer solution of pH 7, okay, then when you are going to dip its electrode into the buffer solution of pH 7, then the digital pH meter, it will show the pH of that solution, it will be 7. So this is how you can calibrate. So here first of all turn on the pH meter, then take the buffer solution, and then take the pH meter electrode from its storage solution and rinse it with the distilled water, and then dip into the buffer solution. Then this pH meter will show the reading of that buffer. That will suppose you are going to take the buffer solution of 7, then the pH meter will show the reading, that is 7. So this is how you can calibrate your pH meter. So these are some steps you can write in your own word also. Then so the next question is there, what is buffer solution, and give its type with example. And this question is for 3 marks. So first 1 mark will be for, you have to explain what is buffer solution. The second mark will be for acidic buffer, means types of buffer solution. In that 2 types are there, acidic buffer solution and basic buffer solution. So there are these 2 marks for the types and 1 mark for the what is meant by buffer solution explanation. Okay, so here buffer solution is what? It is the solution when you are going to add weak acid with the salt of weak acid with the salt of its conjugate base, and this is a resistant to a pH. When suppose even if you are going to add small amount of acidic solution or small amount of basic solution to the buffer solution, then also its pH is not changed. So this is called buffer solution. So it is resistant to pH. There are two types of buffer solution. First one is acidic buffer and second one is the basic buffer. So what is the acidic buffer? So when this acidic buffer, when you are going to add the salt of weak acid in the weak acid, okay. So here you can see the example. Here weak acid is there, acetic acid, and salt of weak acid, that is sodium acetate. When it is mixed, then there is a formation of acidic buffer solution with the strong base. You can add a strong base to that salt of weak acid with the weak acid plus strong base. So this is acidic buffer, how you can prepare. Then basic buffer, how the basic buffer is prepared? So basic buffer is prepared by using weak base with the salt of weak base and strong acid. For example, here you can see that ammonium hydroxide is the weak base, ammonium chloride is the it is the salt of weak base. So this is how you can prepare the basic buffer solution. So just write down these three explanation, then you will get the 3 marks. So this is how you can solve the last year In-Sem question paper, and from this last year In-Sem question paper you can write the answers of this year In-Sem question papers also. So best of luck for your exam.